Walking at 4/7 of his usual speed, Ram gets late by 15 minutes. Find the time in minutes he would have taken walking at his usual speed. So given that Ram is traveling at two different speeds, so one is his usual speed, which let us take this as S1, and he is traveling at another speed which is 4/7 of the usual speed. So 4/7 of S1. Let's denote this as S2. So this is usual speed. Because of this, he is taking different times, right? When traveling at usual speed, he will take usual time. Let us assume this as T1. Because of a different speed, which is 4/7 of S1, he is getting late by 15 minutes. So we can say that T1 plus 15, right? Because he is late by 15 minutes. If he is reaching at 6 o'clock, he will take 6:15 now. Find the time in minutes he would have taken walking at his usual speed. So we need the value of T1. We know that from the basic relation of time, speed and distance, speed is inversely related to time when distance is constant, right? So here the distance is said to be constant only because speed and time are varying, so distance should have been constant. So if we assume this as S1 is proportional to 1 by T1 and S2 will be proportional to 1 by T2. Now taking the ratio of S2 by S1. So from the given relation, which is we have assumed S2 is equal to 4 by 7 of S1. So from this we can say S2 by S1 is equal to 4 by 7. Substituting this value in this proportionality equation, so S2 by S1 will be equal to T1 by T2, right? Because they are inversely proportional. So T1 by T2, this is equal to 4 by 7, right? So from this we can say T2 will be equal to 7 by 4 of T1. So from the given data, we know that T2 will be equal to T1 plus 15. So we can replace T2 by T1 plus 15 minutes will be equal to 7 by 4 of T1. So we can bring T1 terms one side. So 7 by 4 T1 minus T1, it will be 3 by 4 T1 is equal to 15 minutes. So T1 will be equal to 4 into 15 divided by 3. So from this, T1 will be equal to 20 minutes. The answer is option B, 20.